Hi everyone, my name is Dr. Naga Malleswari, Assistant Professor, Department of Mathematics from VNR JYOTHI Institute of Engineering and Technology, Hyderabad. Today I am here to discuss about the topic conformal mapping in complex analysis. Here we have to discuss definition of conformal mapping, different types of transformations and basic transformations like translation, rotation and inversion. Let us begin with the definition of transformation. So another name of transformation is mapping. Let us consider the function y is equal to f of x. Y is equal to f of x is a real valued function. Then the equation y equal to f of x gives a relationship between the points in x plane, x-axis and y-axis. But when f of z is a complex valued function, of complex variable z, a convenient graphical representation is not possible because z and w are two different planes to represent them. The correspondence defined by the equation w is equal to f of z, where u and v are functions of x and y between the points in z plane and w plane is called a mapping or transformation from z plane to w plane. Here the corresponding points w in the w plane are called the images and the points of z of the z plane. Next we discuss the definition of conformal mapping. Consider the transformations u and v. U and v are functions of x and y which maps the points p x naught y naught in the z plane to the point p dash u naught v naught in the w plane. Let C1 and C2 be two curves intersect at the point z naught in z plane is mapped to the curves C1 dash and C2 dash in w plane intersecting at the point w naught. See the graphical representation here. Here we are taking two planes. One is z plane and another one is w plane. In z plane, C1 and C2 are the two curves intersect at the point z naught. In W plane, we are taking C1 dash and C2 dash are the two curves. They intersect at the point W naught. If suppose here theta makes an angle, if it is 30 degrees, here in W plane also it is 30 degrees. So that means if the transformation is such that the angle between C1 and C2 at Z naught is equal both in magnitude and sense. So both magnitude and sense means here if it is angle theta is 30 degrees, in W plane also it is 30 degrees. It is both equal in magnitude and sense to the angle between C1 dash and C2 dash at W naught. So this type of mapping is called conformal mapping at Z naught is equal to x naught, y naught. If the transformation preserves the magnitude but not necessarily the sense, then it is called isogonal. Transformation preserves the magnitude. It preserves the magnitude. Take two planes, Z plane and W plane. Z plane and here it is W plane. In Z plane, x-axis, y-axis. In W plane, here we are taking u, v, because w is equal to f of z is equal to u plus iv, where u and v are functions of x and y. Isogonal means the transformation which preserves the magnitude but not necessarily the direction. Here in Z plane we are taking two curves, C1 C2, intersecting point is Z0. In W plane, we are taking two curves, C1 dash, C2 dash, intersecting point is W0. See here, in this figure it is clearly mentioned, it preserves the magnitude but not necessarily the sense. This type of transformation we call it as a isogonal. Next, conditions for conformal mapping. The sufficient condition for the transformation W is equal to f of z to represent a conformal is, let f of z be analytic function. So analytic function means it is differentiable at each and every point in the z plane. In a domain D of the z plane, let f dash of z which is not equal to 0 inside the domain, then the mapping W is equal to f of z is conformal at all points of the domain D. So this is sufficient condition for the transformation W is equal to f of z which is equal to u plus iv. Next definition is critical points and ordinary points. The points where dw by dz equal to 0 or f dash of z equal to 0 are called critical points, and the points dw by dz which is not equal to 0 are called ordinary points. Function derivative which is equal to 0, it is a critical point. See example problem for better understanding of critical points. Find the critical point of the function f of z is equal to z square. We have to find out the critical point. Function is given f of z is equal to z square. Let us consider the function f of z is equal to z square. How to find out the critical points? We have to find out the function derivative, and that function derivative which is equal to 0. Function f of z is equal to z square. F dash of z is equal to 2z. Here f dash of z is equal to 0. So that means we have to take z value which is 0. Therefore, it has the critical point at z is equal to 0. See another example. Find the critical points of the function f of z is equal to cos z. Given function f of z is equal to cos z. Find out the function derivative. F dash of z is equal to minus sin z. How to find out the critical point? Function derivative which is equal to 0. F dash of z is equal to 0. So f dash of z is equal to 0 means here f dash of z is equal to minus sin z equal to 0. That implies sin z is 0. Z is equal to sin inverse of 0, which we get n pi for all the values of n. The critical points of the function, here function is f of z, f of z cos z, f of z which is equal to cos z is n pi for all the values of n. N is 1, we get pi. N is 2, we get 2 pi. So up to and so on, n terms are existing. Next, some standard transformation here we are discussing now. W is equal to Z plus alpha, where alpha is any complex constant. This type of transformation is translation. By this transformation, every point in the z-plane is displaced in the direction of alpha. Next, W is equal to Z e power I alpha. Here alpha is a real number. This transformation is called rotation. By this transformation, figure in z-plane rotates through an angle of alpha in the W plane. Next, W is equal to alpha Z. This transformation we call it as a magnification. By this transformation, the figure in W plane is magnified alpha times than the size of Z plane. Next transformation, W is equal to 1 by Z, which is called inversion. It reflects opposite of the point of the Z plane. Here are some special conformal transformations. Transformation W is equal to Z square, which is a special transformation. W is equal to e power Z. W is equal to log Z, sin Z, cos Z, sin Hz and cos Hz. These are all some special conformal transformations. Basic standard transformations are translation, rotation, magnification and inversion. Special kind of transformations are Z square, e power Z, log Z, sin Z, cos Z, sin Hz and cos Hz. See example problems for better understanding of basic transformations like translation, rotation and inversion. Find the region in the W plane in which the rectangle bounded by the lines x equal to 0, y equal to 0, x equal to 2 and y equal to 1 is mapped under the transformation W is equal to Z plus 2 plus 3i. We have to find out the region in W plane, which is a rectangle bounded by the lines are given and transformation is also given in the data. W is equal to Z plus 2 plus 3i. First we have to note down the given transformation. Given W is equal to Z plus 2 plus 3i. We call it as equation 1. Let W is equal to u plus iv, where u and v are functions of x and y, and z is equal to x plus iy. Then equation 1 becomes, substitute w and z in equation 1, we get u plus iv is equal to x plus iy plus 2 plus 3i, which is equal to x plus 2, separate real and imaginary parts, plus take I common here, we get y plus 3. Comparing these two, then we get u and v values, where u is equal to x plus 2 and v is equal to y plus 3. Here rectangle bounded by the lines are given. Use these points x equal to 0, y equal to 0, x equal to 2 and y is equal to 1. When x is 0, u is equal to, substitute here x 0, we get u is 2. When, take another point, y is 0, when y equal to 0, v is equal to 3. Next point, x equal to 2. When x equal to 2, u equal to 4, y equal to 1, v equal to 4. Therefore, we get the points like this: 2, 3, 2, 4, 4, 3, and 4, 4. Next. So we have to mark these points. Take two planes. One is Z plane. Next plane, W plane. Because conformal mapping which is a mapping from Z plane to W plane. So that here we are taking two planes. One is Z plane and another one is W plane. Z is x plus iy. So that here we have to mark the points of x. Imaginary point is y. In W plane, here we are taking u, v. On x-axis, here y is 0 and on y, x is 0. Here the points are x is 0, y is 0, x equal to 2 and y equal to 1, which is a rectangle in Z plane. So we get the rectangle like this: x equal to 2, y is equal to 1. Right? Next we have to mark the points in W plane: 2, 3, 2, 4, 4, 3 and 4, 4. Here it is origin: 2, 3, 4, 1, 2, 3, 4. So we get the lines here like this. Mark the points. 2 on x-axis it is u axis. Here we are taking real axis is u. We have to mark the point here: 3, 2, 4, 4, 3 and the point, last point is 4, 4. Join these points which form a rectangle. Here it is 2, 3, 2, 4, 4, 3, 4, 4. Therefore, the region in the W plane which is a rectangle, the given in Z plane it is a rectangle, the region in the W plane which is also a rectangle. So conformal mapping which is a transformation from Z plane to W plane. See another example. Find the image of the triangular region in the Z plane bounded by the lines x equal to 0, y equal to 0 and x plus y is equal to 1 under the transformation w is equal to 2z. Here transformation is given. We have to find out the image of the triangular region in Z plane, and bounded by the lines is also given. X is 0, y is 0, x plus y is equal to 1. So for this first we have to note down the given transformation. Given transformation W is equal to 2Z. Let W is equal to U plus IV and Z is equal to X plus IY. W is equal to 2Z, we call it as equation 1. Using W and Z in equation 1, then equation 1 becomes U plus IV is equal to 2 into X plus IY, implies U plus IV is equal to 2X plus I into 2Y. Comparing these two, we get U and V values. Here U is equal to 2X and V is equal to 2Y. When take the point, first point, X equal to 0. When X is 0, U is 0. Y is 0. V is 0. Next we have to take U equal to 2X and V equal to 2Y. Adding these two, we get U plus V is equal to 2X plus 2Y. Take 2 common here. We get 2 into X plus Y. Line equation is given, X plus Y is equal to 1. In place of X and Y, we have to substitute 2 into X plus Y is 1. We get U plus 2 is 2. U plus V, which is equal to 2. We call it as equation 2. Represent this in Z plane and W plane. Because in Z plane points are given x0, y0 and x plus y is equal to 1. In W plane we get U is 0, V is 0 and U plus V is equal to 2. Take two planes. Z plane W plane, origin, x-axis and here it is y-axis, U, V. X is 0, y is 0 and x plus y is equal to 1. It represents the line like this, x plus y which is equal to 1 in Z plane. Whereas in W plane, U is 0, V is 0, U plus V is equal to 2. On x-axis y is 0 and here on y-axis x is 0. Here in W plane also we have to take U is 0, on U axis V is 0 and on V axis here U is 0. U plus V is equal to 2. This is the line that represents U plus V is equal to 2. In Z plane it is a triangle. In W plane we get the points U equal to 0, V equal to 0 and U plus V equal to 0. It also represents a triangle. Hence, the image of triangular region in Z plane bounded by the lines under the transformation W is equal to 2Z is a triangle in W plane bounded by the lines U equal to 0, V equal to 0 and U plus V is equal to 2. See another example. Find the image of Z minus 2I is equal to 2 under the transformation W is equal to IZ. We have to find out image of circle. Circle equation is given Z minus 2I which is equal to 2 and the transformation is also given, W is equal to 1 by Z. First note down the given transformation. Given transformation W is equal to 1 by Z. Circle equation is given. Given mod Z minus 2i is equal to 2. Mod Z minus 2i is equal to 2 means here 2i which represents a center and 2 is radius. So it is exactly which is of the form Z minus Z naught is equal to R. Z naught is center and R is radius of the circle. Next, let W is equal to U plus IV and Z is equal to X plus IY. Substitute Z is equal to X plus IY in mod Z minus 2i is equal to 2. We get X plus IY minus 2i is equal to 2. That implies X plus, take I common here, I into Y minus 2 is equal to 2. That implies mod of X plus I into Y minus 2 is root of X square plus Y minus 2 whole square is equal to 2. That implies squaring on both sides here, we get X square plus Y minus 2 whole square is equal to 4. Expand this one. X square plus Y square plus 4 minus 2y is equal to 4. Left hand side 4 is there and right hand side 4 is there. Cancel these two. X square plus Y square minus 2y is equal to 0. This represents a circle equation. X square plus Y square minus 2y is equal to 0 represents a circle equation. Compare it with standard circle equation. We get G and F values. Circle equation is X square plus Y square plus 2gx plus 2fy plus C is equal to 0. Here, compare these two. We get F and G values. Here G is 0. F is minus 2. Center is equal to minus G comma minus F. G is 0. F is minus 2. We get the center 0 comma 2. Next, find the radius. Radius is equal to root of G square plus F square minus C equal to G is 0, F is 2, 4, C value is also 0. We get radius is 2. Therefore, center is 0 comma 2 and radius is 2. Sketch the region in W plane, how the circle represents here. Take the plane, x-axis, y-axis, origin, z-plane. Circle equation given is z minus 2i is equal to 2. We get the center is 0 comma 2 and radius r is 2. 1, 2, 3, 4. Here we have to take. This is real axis and here it is imaginary. We get the center point is 0, 2 with radius of 2 units. Mark the point here. R is equal to 2. Draw the circle with radius of 2 units. R is 2 and circle equation z minus 2i is equal to 2. So this is in z plane. Now consider z minus 2i is equal to 2. Given transformation is w is equal to 1 by z. We get z is equal to 1 by w. We have to find out the image in w plane. So that means it is a transformation from z plane to w plane. Circle is transformed to, we have to find out w is equal to 1 by z, z is equal to 1 by w. Substitute in place of z 1 by w minus 2i is equal to 2. 1 by w is u plus iv minus 2i is equal to 2. Take LCM here. We get 1 minus 2i into u plus iv by u plus iv is equal to 2. 1 minus 2iu minus 2i square v by mod u plus iv is equal to 2. Mod 1 minus 2iu, here I square is 1, I square is minus 1. I square is minus 1. In place of I square we have to substitute minus 1. We get minus of minus plus 2v by u plus iv is equal to 2. Separate real and imaginary parts. 1 plus 2v minus 2iu by mod of u plus iv, which can be written as root over u square plus v square, which is equal to 2. Next, that implies mod 1 plus 2v minus I into 2u is equal to 2 into root over u square plus v square. Mod of 1 plus 2v minus I into 2u is root of 1 plus 2v whole square plus 2u whole square is equal to 2 into root of u square plus v square, which implies root of 1 plus 4v square plus 4v plus 4u square is equal to 2 into root of u square plus v square. Squaring on both sides, we get 1 plus 4v square plus 4v plus 4u square is equal to 4 into u square plus v square. Here 4u square is there. we have to note down one more line here. 4v square plus 4v plus 4u square is equal to, multiply it with 4, we get 4u square plus 4v square. In LHS side, 4u square is there, and in RHS side 4u square is there. Cancel these two. Here 4v square is there, and here also 4v square is there. We get 1 plus 4v is equal to 0. 1 plus 4v is equal to 0, which represents a straight line. We get v is equal to minus 1 by 4. Represent this in W plane. W plane, U axis, V, origin. On U axis, V is 0, and on V axis, here U is 0. We get V is minus 1 by 4. V is minus 1 by 4, approximately here we get. V is minus 1 by 4, which represents a straight line. In Z plane, it represents a circle, and in W plane, it represents a straight line. Therefore, it is a transformation from W plane to Z plane, and the transformation given here is W is equal to 1 by Z. Try the following problems using translation, rotation and inversion. Find image of the circle mod Z is equal to 2. Under the transformation, W is equal to Z plus 3 plus 2i. Second question, show that the transformation W is equal to 2Z plus 3 by Z minus 4 changes the circle x square plus y square minus 4x is equal to 0 into the straight line 4u plus 3 is equal to 0. Last question, find image of the line. We have to find out image of the line x is equal to 4 in the Z plane. Under the transformation given here is W is equal to Z square. Try these problems by using translation, inversion and rotation. Thank you.
Like, share, comment and subscribe VNR Digital Learning Resource YouTube channel.